this presentation on the time series modeling on the market price dataset. So what is time series data? The time series data is the type of data that are recorded sequentially at equal intervals of time, that is spaced equally, and this type of data format captures the behavior of a variable or phenomenon over a specific period. Few of the features is that the observations are dependent on each other, the observations are dependent on time, the data is sequential in nature, and time series for patterns focus on the temporal patterns like trend, seasonality, cyclicity, and irregular functions. These all make the patterns inside a time series data. So the methods we have used for modeling time series data include moving averages, exponentially moving averages, ARIMA, SARIMA, LSTM, and FB profit. So 4 of the observations in our problem statement were that we had 120 different markets data. So we had 120 different classes of market and their time series data of the stock prices over years of range. So we used LSTM, ARIMA, and SARIMAX model for building a model for a single market, because the price is only dependent on time in time series modeling and not dependent on different categorical variables. Moving on, the challenges we had faced were that ARIMA was not able to capture the seasonality in the data. There were a lot of missing values with a huge gap, and there were external variables that account for the irregularities in the data. For the challenge of ARIMAX not able to capture the seasonal patterns, it is because it is not built for seasonal data. For seasonal data we can use ARIMAX, and for the missing values we used linear interpolation for imputing the missing values. There are other methods like forward fill, backward fill, seasonal, and trend decomposition. Every of missing values in our use case perform similarly. Generalization of the model to the data is very important, because the market data may fluctuate or be volatile because of the external variables and the irregular patterns in the data, but the model is to be able to generalize to the trend and the seasonal pattern in the data. So generalization is an important aspect to focus on when building time series models. So we are comparing LSTM and SARIMAX. LSTM is a deep learning model and it is very good at capturing the nonlinear relationships in the data. It is very expensive, computationally expensive than the traditional SARIMAX model, and it can handle multivariate analysis or multivariate time series modeling, and SARIMAX model is not able to do multivariate time series modeling. SARIMAX is specifically designed for time series forecasting, and it can also capture linear and non-linear patterns, and it is easy to diagnose the model features of SARIMAX model than LSTM model. So our final outcomes were these models for predicting the single market, and a regression model that is built upon all the markets. So by using that regression model we were able to predict a single market with this amount of good performance. So we can see that even though the actual value is being smoothed, but the predicted values is being able to capture the cyclical and the trend patterns in the data. So thank you, and we will move on to the notebooks. The notebooks we have prepared for the market price prediction. So first we started by doing an EDA. We have taken the data, and we have specified the different characteristics that is present in the data, like the number of markets, number of cities, number of states, and if the data contains duplicate values or not, and the range of years that our data contain, and the oldest and newest date. These are the values for these questions. Then we further filtered out a single market, and when we plotted the minimum, maximum, and average prices, and further we plotted the whole data, and we have sampled the data based on month, quarter, and year, and plotted the different trends. So as you can see, we have a smooth representation of our data when we resample it based on quarter, else based on months, etc. Further, we explored the data, and we got to know that there are some missing values. For example, here you can see there is a flat line in between 2008 and 2010. These values are mostly missing in our data, and we have plotted the data using box plot. By box plot we can also observe the variations in the data and also the outliers. We have further plotted the data, and here it is evident that some of our data is missing. So to impute the missing values, we used linear interpretation. There are other methods like seasonal and trend decomposition, or forward fill or backward fill. So here we have wrote a logic in such a way that we can fill all the missing values based on the time series imputation techniques for all the markets. Then we use this dataset for building the ARIMA-SARIMA models. So here we have also examined the seasonal patterns, the trend of the data, and the external fluctuations that is happening, which we can also call it as residuals. So to determine if the data is stationary or not, we have used the AD Fuller test, and here we can see our data is stationary because the p-value is very less than the critical or alpha values. So further, for the ARIMA and SARIMA model, we need parameters like P, Q, and D. Here the D will be 0 because we haven't done any differencing to make the data stationary. So we have plotted the ACF, which stands for autocorrelation factor, and PACF, which stands for passive autocorrelation factor. So from this we were able to determine the P and Q values. Then we went on checking if checking our model. We have built the model and trained the model. Then we have checked the summary of the model, and here we can see the model is performing quite good, but when we predicted the value and plot against the actual values, we can see that the ARIMA model is not performing as good. Then we went on building a SARIMA model. In SARIMA's model, this model is built to understand and predict on seasonal data. ARIMA model can't capture the patterns in seasonal data, whereas SARIMAX model can. So we have used this SARIMAX model and built a time series model, and here we can see the Remax model is able to capture the patterns, the trends and the seasonal patterns in our data. So this is the performance of all the two models. Remax is able to generalize better to the patterns in the data. Then we have also tried auto arima. In auto arima we don't have to find the values for P, Q and D. The algorithm will find these values by its own. So here also we can see that the model is not performing good. Further, we went on using the LSTM for predictive. Here also we have segregated a single market, and we have modified the features in such a way that it is able to get the past days trend. For that purpose we have used time series generator class in TensorFlow. Then we can also do this manually, but TensorFlow provides this module to make time series analysis very easy. Then we have built a LSTM model. For this LSTM model, the input is the time series generator we have created. Further, we have built the model and check the model performance. Here we can see that the model is able to perform quite good on the data. So this is about the time series modeling. Then we have a data that has multiple classes. So to build a model that is able to predict the prices for each day, also having lots of input, for that purpose we have used regression models. So we have tried different models and we have fixed random forest as the best model. So here are few steps you can do when building a regression model. Here we haven't normalized the input features, but we have encoded the market column. So we have built a random forest and we have done the hyperparameter tuning. These are the best parameters for our random forest model. Then we have filtered out a single market and test our model. Then here we can see that the model is performing quite good